Hey guys, welcome to a new episode. This is, I believe, the second episode, and what we're trying to do here is some kind of a poker prediction system. We have set up the first two cards here, and we have set up a reset button. And this reset, I guess, is temporary for now. I'm going to run the system just to show you what we have. So you select Queen of Hearts, for example, or Six of Spades, or whatever it is. And the next thing you would do is you can reset them if you want. We're going to need this reset later on when we start a new game, for example. You click reset, everything resets for the new game. So this is what we're trying to get to. Now, one thing that I would like to do is, for example, if I do two Jacks of Spades, which is pretty, let's say, impossible for now, I would like it to give me an error that this cannot happen. So that's the thing that I would like to work on right now. So first thing, I'd like to set up an error system, if you will, and that's going to be using this. Let's see, we're going to create a light, which basically I'd like it to turn red when it is on. Dark green is fine for when it is off, but when it is on, I'd like to give it a more reddish bright tint, something like that. So there we go. So this indicates an error. And again, I'm going to call this hand 1 for the label, and I don't want a caption. So I would like this to sit right under each one of these and basically dictate whether there is an error here or not. Can I actually have it under the entire thing, maybe? Yes, I could do it this way. And then select it, and we can do the order and send it to move to back. So there we go. That's 1. That's hand 1. Oh, we can actually even extend it a little further to include the title. There. Or actually let it be that way. There we go. So this is going to be the first one. And then the second one for hand card 2 will be right there, and let's move it back. Oh. Oh. Can we have it sitting inside the cluster? That what just happened. This is interesting. I'd like to see what that would look like. That looks very nice if we can have it inside of the cluster. So basically it lights up behind the cluster whether it is on or off. That is beautiful. Changes the way our clusters work, but that's not a problem. Alright, let's make this work. So I'm gonna make it so that it is as big as our cluster. This is gonna be a challenge. There we go. Select it, go back. Oh. I can't seem to select it anymore. Move to back. Let's see. Okay, so if I take my cluster, make it bigger, then I can select it. I can set it to wherever I want. In this case, I'm going to move it to be just a little bigger than everything. Move it to the back. Get it back smaller. And then make my cluster smaller again. I'm going to move things inside the cluster, kind of just to align them. And hopefully I can make this just one more square smaller. Yep. And there we go. We have a red light in our cluster now, which is green when everything's fine, and it turns red when there's something wrong. So in this case we have something wrong in our hand card 1. Let's see what this would look like. So this changes how this setup works here. So I'm not going to worry about this setup just yet. So there's hand 1 now. 1 has a green light. Let's go ahead and create a hand 2. Very easily we can create a hand 2 which sits right next to hand 1. Perfect. So this is hand card number 2. There we go. Now, how do we deal with these? Let us go ahead and first create an error checking system. So how would we do that? First, this is a cluster. We're going to have to unbundle this cluster and unbundle this cluster. Now, we're going to have to set up something on how to work with this data. Now, this data here, as it is saved, is in a cluster format. And this cluster is way too long. Obviously, we might need to make the cluster smaller. What I would like to do is create a kind of system that would convert this number from here and this number from here into an actual single number, so that it's easier to create different cases out of it. So there we go. So let's run this. So now we have, for example, spades, which is 0, and 3, which we're setting 0, 1, 2, and 3. We're going to have to create a lot of error checking in here and get this to work the right way. I'm not sure what the best option would be. So for the time being, I'm going to keep this as is, and I'm going to create some kind of checking. It would be easier to check the numbers for if they're equal if they had this common system. Okay, so let's do a common system. What I'm going to do, I believe the best thing to do would be, let us go ahead and add these numbers together. Can we do that? Or add this times 10 to this, or 100 plus times 10. If we take one of these and multiply it by 10, and instead of using this multiplier, I'm going to use this expression node here because it takes less space. So if I take the type and multiply it by a number, or take the number and multiply it by a number, I'm going to take the type because the type will always be the third one. Now the type can be 0, and I don't want any zeros. So if the type is, we're going to take the type plus 1 and then multiply it by 100. That's going to be the output of that. While our normal number, which is from 0 to 12 in this case, I'm going to also add, actually what I'm doing right now, sorry guys, but I'm wondering if we should convert this so that the ace is number 13. What do you guys think? Should we set the ace to the number 13 or not? I believe that later on it might be easier to understand what's going on if we set this to the highest number, 13, where number 2, 10, 11, 12, 13, oh, ace could be 14 even. Yes, I'm going to do that. I'm going to represent the numbers as they are. So right now what we have is the number 11, not the number 3. So how do we do that? First, I know the numbers are from 0. So if I do, let's say, and number 0 is the ace. If we subtract 13, that's not gonna help us. If we multiply by a -1 so that they are negative, and then add 14, right? So if we do 14 minus x, what would that give us? Create an indicator. There we go. 14 minus x means Jack is 11. Let's run this continuously so I'll make sure this works. 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. Obviously there is no 1. The 1 is the ace. And then the spades, which we already fixed that. Let me go ahead and show you guys what this would look like. Create an indicator for that. spades is 100. This is going to be run continuously. Hearts is 200, clubs is diamonds 300, and clubs is 400. Now if we go ahead and add these two numbers, if we add this to that and show what that number is, this number right now is going to be the unique identifier of the card. So 402 means clubs 2. Let's run it continuously. 10, this is clubs 10. Spades is 100. Now we don't have any weight on which one of these is strongest. We could do that. We could do the same system so that clubs is 400. So the highest number you can achieve would be realistically the ace. Okay, actually let's go ahead and do that. So let us convert this. We did an x plus 1, so now we just need to do a 4 minus x, and that should pretty much solve our problem. So now we have 410 for the spades, 310 for the hearts, 210 for the diamonds, and 110 for clubs. The absolute lowest is going to be 102, 114 to 414 being the highest possible number. Now, as you recall though, we did add an extra feature where the hand card type can be none. So let's go ahead and do that. If I take this hand, I'm going to create a local variable, create a constant, and set this to blank. Run. I'm just curious, what would the blank show me? So the blank runs up as the number 4, right? Because it's our fourth option. So now we're going to have to do some kind of error checking system where, okay, we all understand how this works. I'm going to get rid of this, and I'm going to move these away and arrange this a little. There we go. So now we know more of how things are happening. So now we have these two numbers. So I'm going to put them all the way out here. These two numbers need to judge whether the system is going to work or not. For instance, the hand card, if this is equal to -1, so let's set that. If this is basically less than 0, less than 0 means -1, and if the hand card 1 type is anything that is 4 or above. Now, if it is a blank, as you can see, it gives us 0. Let me show you what I mean. I mean, if we go in here, and create an indicator, this is actually a great test. Create an indicator for that. Right now it's 0, 0. If we, I'm not sure, did I change that? No. Let me go ahead and set the hand again. Create a local variable, and then let's create a constant. Let me set this to -1. I'm just curious, what are we gonna get on the numbers? As you can see, we get 0 on the hand card, and we have 15 on the number, because -1 is below 0. So we have 0 and we have 15. Oh, this is the type and this is the number. Now I see why this. I was looking at this and I was like, this doesn't make sense. So -1 becomes 15, and hand card type, when there's no type selected, is 0 here. So I can easily access the 0 and the -1. This is less than 0 and this is equal to 0. I already have the less than 0 here, and if I do a comparison to see if it is actually equal to 0. And then if I do a boolean or, so if this or if this is true, if either one of these is true, create, I'm going to do an indicator for now, and let's make it bigger temporarily, and let's run this. So now whenever the system, let's run it continuously, if the system does not know, we have a reset situation going on. There we go. Alright, so now whenever the system is not sure, oh, this is still not selected and it's equal to 0. Why is this not working? there's an error somewhere. If this, this should be from this point right here. There we go. So now when I run it, it gives me an error. Okay, there is an error here because this should be different. So how do we process this error and make it show that, okay, there is an error? The way we would do that simply is we need to select this or this, and to do that we would simply go ahead and take this hand 1 system that we have set up, and oh no, sorry, if we take hand 1, create another local variable for hand 1 alone, what we will do is we will go ahead and now bundle 3 items that will go into this. The third item is going to be this true or false. The second item is going to be the top number as it is, and this one is going to be this type. That should go into that. Now let's run it. So now this tells me, okay, this is wrong. Something is wrong here. Until I have it, now everything's fine. Everybody is happy. There are no more problems going on. That was an accident. There. This will not work here because this setup is already set up. If I reset the system does not want to be reset. Why is this not resetting? When this turns true, it changes the value of hand 1, but this is changing the value of hand 1 as well. I think this is superseding the reset button. So what we might need to do is something a little more creative. If we create a flat sequence and add a frame before it to put this in. There we go. So things were happening, basically this was changing, but this was overpowering that. So now in this scenario, that should no longer be the case. So now that we reset this doesn't work. I need to select something, and I need to select assign until I reset it again. Perfect, huh? Beautiful, beautiful. So let's go back into the system, and let me let me go ahead and simplify everything that we did here and include this new output. This new output is the output of the entire hand card. This one I will need. I will no longer need these test experimental values that I had. This is the only value here that we actually care about right now, and I'll come back to it in a second. Okay, so what I'm going to do now is I'm going to go ahead and make this look prettier. I know nobody likes that. That's what I'm going to do, and I will get back to you guys. See you in a bit. Hello guys. Alright, so I went ahead and I simplified this design so that now it's easier to look at. And what I'm going to do next is I'm going to apply it to the second system as well, to the second hand card that we have here. Let's create another local variable for the second hand and create another, oh, not control, we need another indicator. Here's another indicator and one more local variable for hand number 2 right here to reset it. Let's look at our system, run it continuously. I'm gonna reset the system. So now as you can see, nothing is selected. And even if I select here, still not enough is selected until I select a type. This is satisfied, this is not satisfied. So there we go. We have this system now working. And it actually also shows you here, as you can see, what you have selected. So I have 312, which means a queen of hearts, and 106 is clubs 6. So now we have a single number representing every single card, which will make it easier to handle later on when we're trying to do like a brute force analysis of all the possible combinations and how to basically analyze these combinations. So we'll get to that way later on. I just wanted to set up the initial how to input data into the system. That is the first thing that I'm working on right here. Now, what I would like to do is, in the next video, create some kind of, well, start to create some kind of standardized system, because we only have hand 1, hand 2 here. We're also going to have 3 flops, a turn, and a river. So there's 5 more. There's 5 more inputs to come in to basically define the mathematical system that we're going to have to predict on. And I don't want to have to create this hand 1, hand 2 for every single one. I would like to, for example, have these all connect up to an array which contains all this data built into a single array that you can easily update the array at the end of every cycle. Even if you reset it, then it would update whatever you did reset. So we'll get back to that later. I believe this is enough for now, and I will see you guys in our next video. Thank you for watching.